Question 3. It's an optimization question, but how can we tell it's an optimization question? Well, the key giveaway for it being optimization is to make the surface area is a minimum. Okay? So, we'll start. A cylinder is to be made with an exact volume of 256 pi centimeters cubed. What should be the height and the radius r of the cylinder's base so that the cylinder's surface area is a minimum? So we know straight away that the volume is equal to pi r squared h. So we have straight away 256 pi is equal to pi r squared h, and therefore we have 256 is equal to r squared h. We'll need to come back to that shortly. The surface area is equal to, we have a top, we have a bottom, top, bottom, and we also have the curved area as well. So the top and the bottom are pi r squared, and there's two of them, so it's 2 pi r squared, and we have to add on the curved bit. Now the curved bit is just a rectangle with the height of h, and this is the circumference 2 pi r, so it's 2 pi r h. Now I want to get rid of the h, so from here I say that h is equal to 256 over r squared. So put that into the area equation, or formula. I get 2 pi r 256 over r squared, and we can simplify that down to be a is equal to, and I know I'm going to be differentiating this, so I'm just going to go a bit further. 2 times 256 is 512. 2 at 512 pi, and it's r to the minus 1. Now I'm going to differentiate a with respect to r, so I get 4 pi r minus 512 pi r to the minus 2, and we want to make that equal to 0. Just to help me with my calculations, I've rearranged it like as so. If I times everything up by r squared, I get 0 is equal to 4 pi r cubed minus 512 pi. I'm going to do a bit of rearranging. The pi's cancel. So r cubed is equal to 512 over 4, which is equal to 128. So we have r is equal to the cube root of 128. I'm going to keep the exact value in because the question asks what should be the height to h and the radius r. So I need to go back to that to h, and I'm just going to hopefully get this. Will I be able to paste? There we go. And so I get h is equal to 256 over and I'm going to use my calculator to do all of this. and that's equal to 10.0794, and I'll just check the units, centimetres, and that's rounded to 6 sig figs, and therefore, and we know what r is for rho 4, which is just the cube root of 128, which is 5.03968, again, centimetres to 6 sig figs. Just make sure I've got all the calculations right, I'm happy with that. Now, does it ask me to check if it's a minimum? No, it doesn't, but it's always a good practice, so I'll put this in a different colour for us. So we know that we're having to differentiate this again. So d2a by dr squared is equal to 4 pi minus, but double minus is 512 times 2 is 1024 pi r to the minus 3. Substitute r into it. And I put r into it, I get and r was the cube root of 128 to the power of minus 3, and I get, I need it to be a maximum, it's going to be 4 pi plus 8 pi. So minimum, which is what we want. And how many points was that worth? That question was worth 4 points.